Hey guys, I'm Pat Kelly. Okay, in this problem, they ask us to find the area of the region bounded by these equations. And then they also say to verify using a graphing utility, just to give you that warm fuzzy feeling that you did it right. Okay, so if they say to find the area that's going to be bounded by these equations, I hope that reminds you of the problems you used to do a while back. It's back in the day when you did area under the curve problems, it came down to an integral. Okay, so that's good. We know how to do our integrals, but we'll also have an exponential involved here, and that's the new element. Now with those problems where we're finding the area, typically it's a good idea to start with some kind of sketch, and even just a rough sketch. And that's just so you don't hit any hiccups with where, do you remember? Sometimes the top curve and the bottom curve kind of switched roles. There's nothing goofy going on with this one, but I still like to see a rough idea of what this region's going to look like. So y equals 0, that's always just your good old x-axis. X equals 0, that's your y-axis. And then x equals 6. 1, 2, 3, 4, 5, 6. That's just going to give us a right boundary. So we have a bottom, a left, and a right boundary. And then that initial equation, probably the important one, that's going to give us the top. Y equals e to the x. That's the new stuff. You should know basically what the graph of that looks like. Our good old exponential growth is just going to keep going up, 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 right? And I'll just finish off the region, but I really need to warn you that my drawing is absolutely not to scale, okay? Because this was an x value of 6, right? E to the 6 is, I don't know, off the top of my head, somewhere around 403. So it's way up there. And I know I'm not impressing you, I did it ahead of time, okay? But that's just a rough idea that that whole area under the curve type problem is going to be very well behaved. I have a left, I have a right, I have a top, I have a bottom. Let's get to it. So the area equals the integral. My left x value is 0, my right x value is 6, my top curve is that e to the x. The bottom is 0, and I don't even need to write that. Remember, that would be like subtract 0. So I'm ready for a dx, and you're done with the setup of the problem. It's very friendly. Now let's actually do the problem, which involves the new material of integrating exponentials. So when I get into this integral, and I'm ready to anti-differentiate that e to the x, your new material, oh yeah, the integral of e to the x is just e to the x. It's so friendly. And I need to evaluate that from 0 to 6. Okay. So I'm plugging in that top value of 6, plugging in that bottom value of 0, and e to the 0, let's just do that one right now. That's 1. So e to the 6 minus 1. And you'd be done with that. I mean, no simplifying, and I like that package as a final answer. But I think I'm going to grab a calculator and find out what the decimal equivalent will approximately be, only so that when I do the second half of the directions and verify with the graphing utility, we'll see the same kind of format, decimals. So I'll grab my calculator and just enter e raised to the 6th power, subtract 1, and approximately 402.43. Okay, good final answer. Now they do also say to verify that, get that warm fuzzy feeling by confirming it with a graphing utility. So your choice of graphing utility, just go into your y equals and enter your original function, e to the x, as your y equals e to the x. I'm going to graph that. Looks pretty good, except again, mine's not to scale, right? Now let's get that same decimal answer if you use your calculus features to try to find the integral of this function from 0 to 1. Sorry, 0 to 6. Double check that. 0 for lower limit, 6 is upper limit. And just a quick comment here, because this is a common error. If your graphing utility kind of gives you a problem right now, check that your window does go at least as far out as 6, okay? Mine was zoomed in from a previous problem. Yours might be as well from some homework. So I'm going to get out of that error and just do kind of a standard zoom. Make sure you can get at least 6 out on the x-axis. Okay? And then try that integration feature of your graphing utility again. 0 lower limit, 6 upper limit. Utility thinks for a little bit and tells me 402.43 with rounding. So we got it right. Okay? I like this problem, just reminds you of the old area under the curve problems, but you will see exponentials now, and you know how to handle them.